Good day, everyone. Welcome to That Friendly Writer Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about hypothesis testing using the one-sample t-test. Take note that this is only for a one-tailed case. Alright, let's get started. In hypothesis testing, the t-test is a common statistical technique. There are various types of t-tests, but they still have the same purpose, to compare. We have the one-sample t-test, the dependent t-test, and the independent t-test. In this video, we will only focus on the one-sample t-test, whose formula is very familiar to us at this point. Also, we will only focus on the one-tailed version, which compares whether the mean of a single sample is significantly lower or higher than a standard or hypothesized mean mu. What do we mean by comparing to a standard? Let's have an example. Did you know that in agriculture, standard plant heights average about 20 centimeters? This is the standard. Now, this situation shows that this woman is worried because she claims her plants seem to be shorter than 20 centimeters. This is her claim, which is also the alternative hypothesis. We may use the symbol mu is less than 20. And because we are after whether the plant height average is shorter, this implies a negative or left direction. So this is a one-tailed, specifically to the left. So what is the null hypothesis? That the mean mu is equal to 20. Remember that the null hypothesis is a condition of no change, so we always use the equal sign. Now that we have our null hypothesis, let us complete the statistical table in front. First is the sample mean, x bar equals 18. Our sample size, by the way, is n equals 5. We also calculate the standard deviation SD, which is 0.71. Next, using the four values, we can use the one-sample t-test to calculate the t-statistic of negative 6.30. The critical value, negative 2.132, comes from the t-table. Remember, this is one-tailed, so we look at the one-tailed column. Sample size is 5, so the degrees of freedom is 4, and alpha of 0.05 is sufficient. The p-value is generated by a computer. We will not compute this manually, but we still need to provide this. The table now shows that negative 6.30 exceeds negative 2.132. Also, the p-value of 0.001 is very, very low, which tells that this phenomenon is a rare event, assuming the null hypothesis is true. Hence, the evidences tell us to reject the null hypothesis and claim that the difference is significant. What does this mean? That the sample of plant heights of 18 cm is significantly shorter than the standard plant height of 20 cm. Now, why is this so? It is up to the researcher to give meaning to this. Plants become significantly shorter, maybe because they don't have enough water, or some studies say that talking to the plants may help, which the person must not be doing, or something must be wrong with the soil. We were able to recognize that this shortedness in height is significant, but it is up to us to give meaning to the data. How about a second example? A company usually makes batteries that can last up to an average of 300 minutes when used nonstop. This is the standard. Now, take a look. The same company said that they have made a newer battery that has a longer battery life than their usual of 300 minutes. This is the alternative hypothesis, their claim. We can use the expression mu is greater than 300. This is one-tailed because the direction is positive or to the right. What is the null hypothesis? Always use an equal sign for the null hypothesis, that the mean mu is 300 minutes. Now that we have the null hypothesis, let us fill out this statistical table. We calculate the sample statistics. First is the sample mean x bar. The sample size is n equals 8, by the way. The standard deviation is also calculated. The t-statistic of 1.00 is computed by substituting the values in the one-sample t-test formula. The critical value of 1.89 is obtained from the t-table. This is one-sealed. We also need to use the correct degrees of freedom. The p-value is 0.18, which is computed by a software. We will not do this manually. The table shows that the stat of 1.00 did not exceed the 1.89 critical value. The p-value is also 0.18 or 18%. This is still a common phenomenon, assuming the null hypothesis is true. Therefore, we cannot have enough evidence to reject the null. So, no significant difference is between the standard and the sample mean. What does this imply? We are implying that the claim that the new battery model has longer life does not have sufficient evidence based on the given sample. Versus the standard of 300 minutes, the sample mean life of 305 occurred only by random chance. This could mean several things. One, the seller could just be saying this to sell batteries, or the company failed to do it right. I hope with the given examples, we were able to give light on the importance of the t-test. With the t-test, we are able to compare a sample from a known standard or population mean mu. But I would like to give importance that the results and conclusions we can give using the t-test may only be valid if our data assumes the condition of normality. This is a very important thing to check first before using the t-test. Now, going back to the salesman, there was no evidence to say that the sample mean is significantly higher than the standard. We have to understand that there is still the possibility of error, type 2 in this instance. Remember that type 2 error is when we rejected the null due to lack of evidence. If the salesman was honest and truly selling an upgraded battery, the salesman would be feeling sad right now. I mean, we only had a sample of 8 batteries to test. Perhaps the conclusion would have been different if we used a larger number of sample size batteries? We can only guess. There we go, hypothesis testing using the one sample t-test. For your practice, read a standard you see in front. Pause for more time. Now, what is the alternative hypothesis? What is the null hypothesis? I will reveal the answer in 3, 2, 1. These are the hypotheses. We are now ready to set up the statistical tables. Give n, the sample mean x bar, and the standard deviation SD. I will reveal the answers in 3, 2, 1. These are the values. Next, fill out the table. I will reveal the answers in 3, 2, 1. These are the inputs. So, which hypothesis did you take, the null or the alternative? What does the result mean? I will reveal the answer in 3, 2, 1. So, how did you do? Were you able to solve the problem? Alright, this concludes our video for today. Hope you learned something new and have a friendly day.